welcome back to the channel. In this video, I am going to discuss Cambridge IGCSE Physics, Paper 4, Theory, Extended Paper, October-November 2024, Paper 42. So are you ready? Let us get started. Now, let us look at the first question. But before I start with the first question, I want you to pay special attention to the gravitational acceleration, or the acceleration of free fall has been changed to 9.8 meter per second square. So you have to use this value instead of 10. Now, let us start with the first question itself. Number 1A, a rocket has an initial mass of 7.4 times 10 to the power of 6 kilogram. First part, calculate the initial weight of the rocket. Now, how do you calculate the weight? There must be an equation that you're using, right? So do you still remember W is equal to mg, where W represents the symbol of weight, M represents the symbol of mass, and G represents gravitational acceleration. So the mass is 7.4 times 10 to the power of 6. G, remember, use 9.8. So you should get 7.25 times 10 to the power of 7 Newton. Or you could round it off to 7.3 times 10 to the power of 7 Newton. Now, a special reminder here, before you write down your final answer for weight, you have to bear in mind that the final answer must be denoted as 2 to 3 significant figures only. So we can accept 7.3 times 10 to the power of 7 Newton or 7.25 times 10 to the power of 7 Newton. So the second part, defined in words the term weight. What is weight? Weight is actually gravitational force acting on a mass. That is called weight. So I hope you're clear on that. Now I would like to continue. B. Fig 1.1 shows part of the speed time graph for the rocket as it leaves the ground and travels into space. This is a graph. The first part, describe the motion of the object from O to A. Now I want you to pay special attention from O to A. Let me use the highlighter to show you. This is O and this is A. So when the question asks you to describe about the motion, you have to describe it in terms of how the rocket is moving. So look at the y-axis. This is a speed graph. Speed against time graph. You know that when a graph is being given, there are two information that you could obtain from the graph. One is the area under the graph. The other one is the gradient under the graph. The area under the speed time graph doesn't give you the motion of the rocket. It will just give you the total distance traveled by the rocket. Right? So when you describe about the motion, you need to describe whether the rocket is moving faster and how fast is fast, whether the rocket is accelerating or not accelerating or decelerating. So I could see that this is a curve graph. To find the gradient of the curve, you need to draw tangent. Right, so I'm going to draw a little bit of tangent right here so that you can see it clearer. I'm going to use green color right here. So I want you to see this, pay special attention to this. From O, could you see that these are the tangent lines that I am drawing? It is getting steeper. So how do I know it is getting steeper? Because it is getting more straight. Towards y-axis, getting more straight, we call it as tangents are getting steeper. So when it is a curve graph, you have to draw tangent. When you look at the tangents are getting steeper, that also means that the gradient of the graph is increasing. So when the gradient of the graph is increasing, what represents the gradient of the speed time graph? It is acceleration. So in other words, we say that the acceleration from O to A, acceleration increases. It cannot be uniform because it is a curved graph, so the gradient would never be uniform. What about from A to B? Wow, from A to B, this is a straight line graph. Don't you think so? This is a straight line. If it is a straight line, you learn math, you definitely know that a straight line graph will always give you constant gradient. Since the gradient of the graph represents acceleration, so I would just say that acceleration is constant. Or you can say uniform acceleration, doesn't matter. So that is the answer. Now, draw a tangent to the graph at time t equals to 400 seconds and use this to calculate the acceleration of the rocket at this time. Show your working. So why do they ask you to draw tangent? Because if they want you to find the acceleration, it is a curved graph, you need to find the gradient from the tangent. So I have already drew my tangent. I want you to focus only on my orange straight line. So I'm going to highlight that. Could you see that? This is my tangent. Okay, this is it. I want you to focus on this one only. Tangent is a straight line that will pass through that point. At 400 seconds, I want you to see it clearly. This is 400. I have already put the point up here, which is this one. So I draw a straight line that passes through that 400. So I got my 2 points here. One is this one, the other one is this one, right? And then now I'm going to read this. This is 220, and this is 600. I have two coordinates. I based on only my tangent to find the gradient. Now this one is, let me see. This is 580. X-axis is 580 and y-axis is, I get exactly 8,000, so it is 8,000. Right, now I scroll down a little bit, draw tangent, use this to calculate the gradient, to calculate the acceleration. So I need to write this now. Acceleration is equal to the gradient of tangent that I drew. So gradient is y2 minus y1 divided by x2 minus x1, right? So I'm going to move it. So y2 is 8,000 minus 600. 8, oh yeah, okay. This is 8,000 minus 600 divided by, what is this? Divided by 580 minus 280. So 580 minus, is it 220? I'm sorry, 220. So use the calculator. 8,000 minus 6,000 divided by 580 divided by 220. And I got 8,000 minus 600. I'm so sorry, I minus 6,000. That is why I didn't get the nice value of 580 minus 220. And that will be 20.55 meter per second square. But hey, remember 20.55, that is four significant figures. Therefore, I have to round it off to minimum of 2 significant figures and maximum of 3 significant figures. So I'm going to round it off to 20.6 meter per second square. So 20.6 meter per second square, 3 significant figures. And I want you to remember as well the mark scheme. Acceleration, of course, the range is being given. The range is 17 meter per second square to 23 meter per second square. So my acceleration is within the range. Phew, right? Okay, I hope yours are in the range as well. Now let us look at part C. Rockets are used to launch satellites into space. When the satellite is released, the rocket returns to the Earth. Explain in terms of forces why the rocket reaches terminal velocity as it travels through the atmosphere back to the Earth. Now, before I answer this question, I would like to do a little bit of recaps on terminal velocity. So do you still remember what is terminal velocity? I will write this down. Terminal velocity is actually the maximum velocity of the rocket, right? Of rocket in this case, when resultant force acting on rocket is 0. That also means that all the forces acting on the rockets are balanced. Now, let me explain in terms of forces because it is definitely more than one force. Right. So, in terms of forces, I would say that there are two forces acting on rocket as it is traveling towards Earth, right? Which are weight, that means the weight of the rocket, and air resistance. Do you still remember about the air resistance? Air resistance can only act on the object when the speed of the object, when the object has speed. Since the rocket traveled back to the Earth, the rocket definitely has its own speed. Right. Um, Terminal velocity, I say terminal velocity is reached when air resistance on rocket, acting on the rocket, equals to weight of rocket. So because air resistance is the force that opposing the motion of the rocket, and the weight is going downwards. So air resistance is acting upwards. So upward force is balanced by the downward force. That is why the rocket will move at terminal velocity. Now, second question, Fig 2.1 shows a golfer about to hit a golf ball with a golf club. The initial momentum of the golf ball is 0. A, define momentum. So if you want to define momentum as a product of mass and velocity, feel free to do so. Or you can write momentum is mass multiplies by velocity. Not a problem. Now B, the golf club is in contact with the ball for 5 times 10 to the power negative 4 seconds. Velocity of the golf ball as it leaves the golf club is 41 meter per second. The golf ball has a mass of 0.046 kilogram. Calculate the impulse on the golf ball. Now there are two equations for impulse. I am going to write here. Impulse can be calculated by two equation. One is the force multiplies by time. The other one is the change in momentum. Now, I'm not going to use the first one because the force is not being given. So definitely, I'm not going to use the first one. I am going to use the second one, which I'm going to write it as impulse equals change in momentum. So mass of the golf ball is 0.046 and the velocity of the golf ball is 41 and minus the initial velocity of the golf ball. I want you to see this. Pay special attention to this. Initial momentum of the golf ball is 0. So make our life easier. Don't you think so? Right? So I put here as 0. So when you use the calculator to calculate, this is 1.89. I put it in terms of three significant figures. So 1.89 kilogram meter per second. 1.89 kilogram meter per second. Done. The second part, calculate the force applied to the ball by the golf club. So force is equal to rate of change of momentum. Rate of change, that means change of momentum divided by time taken. So change of momentum, I have already have the answer. So I just put 1.89 and the time, which is given as 5 times 10 to the power negative 4. So this is 5 times 10 to the power negative 4. Another thing that I want to remind you is that whenever you key in the value into your calculator, remember to put a bracket here. Just to avoid careless mistake. So you should get 3772 Newton. Oh, that is 4 significant figures. So it is not allowed. So I'm going to round it off to 3800 Newton. So 3800 Newton is my answer. That's 2 significant figures. Now, number 3, state 2 energy resources for which radiation from the sun is the main source of energy. So there are so many. I'm going to write down one is wind maybe, and the other one water, which is related to water. I put hydroelectric, or you could put coal, etc. Now, B, a wind turbine is used to generate electricity. The useful output from the turbine is 1 second is 6,000 joules. The kinetic energy of the wind hitting the turbine in 1 second is 11,000 joules. Velocity of the wind hitting the turbine is 6.3 meter per second. First part, show that the mass of air hitting the turbine every every second is approximately 550 kilograms. How do you show that? So since this is related to mass and the kinetic energy is given, but this is a mass of air, that is why I have to be extra careful. So the kinetic energy must be kinetic energy of the air or of the wind in other words. Okay, if you want me to write wind, then I will write down wind because wind depends on the movement of the air, remember? So half mv squared. Kinetic energy of the wind is 11,000 and the mass is the one that I have to find. And the speed of the wind, the velocity of the wind hitting the turbine, which is 6.3, you square it. Now I have 11,000 is equal to, if I square it here, I get 19.845 m. Therefore, the mass is 11,000 divided by 19.845, which is equal to 554.3 kilogram. Now, this is what I call intermediate answer. When the question asks you to show the final mass to be approximately equal to 550 kilogram, you have to show the intermediate answer before you round it off to 550 kilogram. That will give you that 1 mark there. Now, the second part, calculate the efficiency of the turbines. You may assume that all the kinetic energy stored in the wind is transferred to the turbine. Now, efficiency, if you remember, since the energy is being given, I will put useful output energy divided by input energy multiplies by 100% because you look at the unit given, that is percent over there. So the useful output energy is the energy, useful output from the turbine, which is 6,000. So I'll put here as 6,000. Input energy is the energy from the wind, which is 11,000 times 100%. So I round it off to 55%. That is two significant figures over there. Now, C, tidal energy and wind energy are both renewable energy resources. State one reason why tidal energy is more useful energy resource than wind energy. Ignore the cost of construction and the maintenance. So you look at the wind energy, right? It is not to say that when I wish, please have wind today, I'll get wind, right? Wind is not always there. Wind is not always there. But for tidal, the beach is there, the sea is there. You can get tidal energy all the time. So I said that, okay, tidal is more reliable. Tidal energy is more reliable as compared to wind energy. Because wind is so unpredictable. It's not to say you wish for wind and wind will come, right? Now, number 4. Fig 4.1 shows a pressure cooker, don't get pressurized, on an electric heating element. The cooker has a tight fitting lid. Have you ever seen this before? I used this before. Used to boil some corn, right? It is not so nice to use actually, quite heavy. A, the pressure cooker is half full of water. As the water is heated, some water evaporates before the water boils. Describe two differences between evaporation and boiling of the water in the cooker. Now, first difference is evaporation occurs at any temperatures. Yeah, even though cold temperatures, evaporation could also occur, whereas boiling occurs at fixed temperature. That is the first difference. And then evaporation, this is the second difference. Evaporation occurs at the surface. Remember, surface only. Surface of water. Whereas boiling, if you cannot read my handwriting, please do comment below if you want me to write it nicer. I don't want to be a doctor. Whereas boiling occurs throughout the water. These are the two differences between evaporation and boiling. Now, B, as water is heated, the pressure of the gas inside the cooker increases. Explain this increase in pressure in terms of particles. So you have to focus on the particles of water. 4 marks is given here. So I would say that water particles gain kinetic energy due to the temperature of the water increases. Remember, temperature is directly proportional to kinetic energy. So, okay, water particles move faster and collide with wall of cooker more frequently. Okay, there is a larger change in momentum of water particles, rate of change of momentum or rate of change of larger momentum gives rise to larger force. So pressure is equal to force over area. Since the force increases, that is why the pressure of the cooker increases as well. So these are the answer. Feel free to pause the video at any point, right, if you want to write down the answer. Number 5, on a sunny day, the temperature of a black tarmac road and the air above the road increase. A, explain why the surface temperature of the tarmac increases. First of all, they talk about the tarmac, which is black color. Don't you think that black color is a good absorber of the heat? In fact, it is the best absorber of the heat. If you don't trust me, just wear black color shirt, or just like me, right? Stand under the hot sunny sun. Yeah? Look at what you become. Look at my hair, all black, right? So the surface temperature of the tarmac increases. It is due to black itself. Black color is a good absorber of heat. Okay, and the second mark, which absorbs infrared from the sun. That's it. Now B, state the method of thermal energy transfer from the tarmac to air. So air is on top of the tarmac, immediately above the road. So this is called conduction, yeah? So there are 3 methods of how thermal energy is being transferred: conduction, convection, and radiation. So conduction, that means there is a physical contact, yeah, between the tarmac and the air above it, right? C, state the main method of thermal energy transfer from the air immediately above the road to the rest of the air. So air to air, this is called convection, circulation of heat. So the hot air will rise and the cold air will come down and absorb the heat from the tarmac. Right? Now, D, explain why the surface temperature of the tarmac is higher than the surrounding air temperature. So one of the reasons is because black color is the best absorber of heat, is the best absorber of heat, and the tarmac emit heat slower because it can absorb a lot of heat, so it would take longer time to emit heat compared to air. That is why the surface temperature is higher as compared to air. Now, question number 6. A student placed the violin near the doorway to a large room. Fig 6.1 shows a young teacher standing where he can hear the sound but cannot see the student. A, part 1, state the wave effect that allows the young teacher to hear the sounds from the violin at the position he's standing. So you look at the door, open door, only this part. Yeah? as if there is an opening, a small opening. Remember, the effect is called diffraction. Diffraction means the spreading of the sound from the violin through an opening. Now, second part, calculate the frequency of sound with a wavelength of 0.75 meter. The speed of the sound in air is 340 meter per second. So do you still remember the wave equation? V equal to F lambda, where V represents the speed of the wave, F represents the frequency of the wave, and lambda represents the wavelength of the wave. Now we are asked to calculate the frequency. I will put the frequency as the subject. V is 340 and the wavelength is 0.75, and you're supposed to get 453 hertz. I put it in terms of three significant figures. Of course, you can put it as 450 hertz, right? That is two significant figures. Now, the third one, a violin produces sounds in the frequency range 200 hertz to 3800 hertz. The width of the open doorway is 0.75 meter. Explain why the young teacher hears the frequency calculated in A part 2 clearer, but finds a frequency which is higher a little bit, much harder to hear. Now, I want to explain in terms of equation, V equal to F lambda. Since the sound wave travels through air, so the speed of the air is unchanged. It's just the same because there's no temperature change, so the speed of the air will remain constant. Frequency is inversely proportional to wavelength. So could you see that when when the frequency is lower, the wavelength is larger? Now, but when the frequency is higher, 3500, the wavelength will have to decrease. The wavelength, the length traveled by the wave will decrease, right? So the width of the door maybe has a larger distance as compared to the wavelength. So that is why it is harder to listen. I would say that, yeah, less diffraction will occur. So diffraction, the best diffraction is actually when the opening, the width of the doorway is almost similar to the wavelength. Right. So because the wavelength is 0.75, which is exactly the same as the width of the open door. That is why maximum diffraction will occur. That is why the teacher could listen to the sound of the violin clearer. But when the wavelength decreases and the width of the opening, which is larger than the wavelength, right, less diffraction will occur. Less diffraction, so the teacher couldn't hear it clearer. Right? So when frequency increases, the wavelength decreases. I say that as the speed of the sound. Speed of sound is constant. Yeah. So hence less diffraction occurs. That is why the teacher couldn't hear it clearer. Now B, a plane mirror is placed at point X so that the teacher can see the student. On figure 6.1, draw a light ray from the violin to point X and from point X to the teacher. I am going to draw it right now. So violin to point X. Okay, let me shift my ruler a little bit. Where is you? Where are you, violin? Okay, this is here. Violin. Okay, towards point X. Okay, this is it. Violin to point X, and then point X to the teacher. Okay, where's the teacher? Teacher is here. Okay, teacher, this is you. So towards you. Okay, done with that. Let me scroll down a little bit, see what else that I need to draw. Draw and label the mirror. Okay, where is the mirror? Okay, mirror is supposed to be somewhere here to reflect the sound to the teachers or to reflect the light to the teacher, right? So I'm going to draw a mirror right here. Okay. Okay, this is my mirror. Keep the ruler. And I label this as mirror. You can draw a straight line, doesn't matter. A slanting line. And an arrow to the ray to show how the teacher sees the student. So do you still remember the reflection rule? So angle of incidence. must be equal to angle of reflection. So that is why I draw that mirror over there. So the arrow must be coming from the violin to the teacher, or from the student to the teacher, so that the teacher can see the student. That's it. Now, number 7, a washing machine has an electric motor and an electric heater. Fig 7.1 shows a simplified circuit diagram for the washing machine. The heater has a resistance of 25 ohm. I am going to write it down here. And the power supply has an electromotive force of 230 volt. State the meaning of electromotive force. Normally, they will give you 2 marks. So what is the meaning of electromotive force? It is defined as energy supplied by a source in driving a charge through a complete circuit. That is the meaning of EMF. Energy supplied by a source, 1 mark. Driving the charge through a complete circuit. That's another mark for you. Now, state the potential difference across the heater. Could you see that the heater and the motor are being connected in parallel? So in parallel, they share the same PD, 230 volt. And C, calculate the current in the heater. So I'm going to use Ohm's law, V equals to IR. Could you see that? Focus only on the heater. So I'm going to find 230 I current, and the resistance of the heater is 25 ohm. I is equal to 230 divide 25. You get the current of 9.2 ampere. So 9.2 ampere is the answer. D, the current in the motor. Wow, the current in the motor. This is 9.2 ampere, and this is 1.6 ampere. Determine the reading on the ammeter. Could you see the ammeter is measuring the total current of the circuit? How do I know? Let's say this is positive terminal, this is negative terminal. Current that is coming out from the positive terminal of the power supply would split to heater and to motor before combine back to be the same amount of current that flowing back to the negative terminal. So just remember that, right? So the ammeter reading will be 9.2 ampere plus 1.6 ampere, which is equal to 10.8 ampere. So the ammeter reading is 10.8 ampere. Right. So the total current, since, okay, I write down, since this is parallel circuit, okay, for parallel circuit, let me write it down. For parallel circuit, current, total current measured by ammeter splits to motor and heater at a junction. Junction is the point where the current split. In our case, this is what we call junction. Right, so that's the answer. Now, question number 8. A fisherman uses a high-frequency sound wave to locate the fish in the sea. Fig 6.1 shows the sound waves emitted from the boat. A, state the name of the sound wave which have a frequency greater than 20 kilohertz above our audible range. That is being called ultrasound. B, high-frequency sound waves travel from the boat through the sea water. Speed of the sound wave, sound in water, is 1,500 meters per second. The seabed is 22 meters below the boat. Calculate the time taken for the boat to receive the reflected. Whenever you see this word reflected, always write down the equation of speed as 2 times the distance, because the sound must travel to and fro per time taken. So speed is 1,500, distance is 22 time. So time is 44 divided by 1,500. So that is why you get 0.029 seconds as the time. Now see, fig 8.2 shows a fish below the boat. Describe and explain how the reflected sound wave received by the boat from the fish differs from the reflected sound wave received from the seabed. I want you to see, this is the whole seabed over here. And look at the fish, this part only. So of course, more sound wave will go to the seabed, and reflected sound wave of the seabed would be higher than frequency of the reflected sound wave from the seabed would be higher than the frequency reflected by the fish due to the small surface area of the fish. So I will explain this. I said that reflected sound received from fish is lower, right? Due to smaller surface area of fish as compared to seabed. Now, let us look at question number 9. Fig 9.1 shows a wireless charging plate used to charge the battery in a mobile phone or your cell phone. The coil of wire is part of an electrical circuit. The charging plate is connected to an AC power supply. The power supply is turned on. A, describe the magnetic field around the charging plate in terms of the magnitude. So you have to see the magnitude as well as its direction. So I would say that since this is AC power supply, it will give rise to varying magnetic field around the charging plate, and it gets weaker, okay, magnetic field, because I have to compare magnitude. Field gets weaker when it is away from coil of wire of charging plate. That's it. B, a mobile phone is placed on the charging plate as shown in Fig 9.2. The coil in the mobile phone is part of the separate circuit that charges the battery. The coil in the charging plate and the coil in the mobile phone act like a transformer. Now the first part, explain why there's a current in the secondary coil shown in Fig 9.2. The way to explain this is exactly on how you explain the working principle of a transformer. So let us explain this. I would say that the varying magnetic field from charging plate is being cut by secondary coil. Secondary coil, which causes a change in the magnetic field. A change in magnetic field induces current in the secondary coil. That's it. Now, the second part suggests why the transformer made from the charging plate and mobile phone is not 100% efficient. So this is true because we human who invented it is not perfect, but that's not the answer. I just want to say that, right? It is because that sometimes you're talking about charging plate, right? And then we are surrounded by many magnetic materials nearby. Maybe the magnetic field that is coming out from the charging plate is being attracted to magnetic materials nearby. And when you charge your phone, when you touch the charging plate and you touch your phone, right, there's a little bit of heat there because some of the energy is dissipated as heat to the surrounding. And that's the reason. So I would say that maybe, okay, if you want the answer to be easier, you can say that some energy is lost to surrounding. That would be easier way to say it because this is only one mark. Now, see, the mobile phone battery can be recharged using this charging plate and stores 4.5 times 10 to the power of 4 joules of energy when fully recharged. The current in the secondary coil is 0.63 ampere when the output voltage is 12 volt. First part, calculate the time taken to fully recharge a completely uncharged battery. So I am going to use this equation E equal to VIT because V is given, I is given, right? The energy is given as well, 4.5 times 10 to the power of, let me see, to the power of 4 is equal to 12 volt times 0.63 ampere and times the time. So the time that I got, this is 4.5 times 10 to the power of 4 is equal to 7.56 T. So the T is 4.5 times 10 to the power of 4 divided by 7.56. So here I got 5952.4 second, right? Or you round it off to 5950 or 6,000 second is also okay. Or you round it off to 6,000 second. 6,000 second. If you want to put as 6,000 second, doesn't matter, but or you want to change it to minute, which is 99 minutes. I actually changed it to minutes because the question did not ask me to put in second. Right. And the second part, calculate the charge passing through the battery in 60 seconds. Remember how you kill it. Charge is the Q, right? So I current is 0.63, time taken 60 seconds. Don't copy the time that you have calculated. So 60 seconds, which is equal to 37.8 coulomb. Coulomb is the unit of charge. Remember that. Now, the next one, question number 10. Carbon-14 is a radioactive isotope of carbon. Carbon-12 is not radioactive. A. Explain how a carbon-14 differs from an atom of carbon-12. I said that 14C, I can use this, save my time in writing and save your time in writing as well. Carbon-14 is heavier. I would say is heavier than carbon-12 due to its larger mass number or nuclear number. 14 and 12, right? 14 is larger, that's why it is heavier. And also carbon-14 has, this one is 8, right? 8 neutrons, whereas carbon-12 has 6 neutrons. That's it. Now B, all living organisms contain both carbon-12 atoms and carbon-14 atoms. The ratio of carbon-14 to carbon-12 is 1 times 10 to the power 12. Carbon-14 has a half-life of, wow, that is so long, 5,700 years. First part, when an organism dies, no new carbon is absorbed. The amount of carbon-12 in dead organism remains fixed. Describe how the amount of carbon-14 in the dead organism decreases with time. So this is the decaying graph. It has to decay exponentially. So I would say that the amount or the number of carbon-14 decreases by half of its initial amount for every 5,700 years. You know why? Half-life means the time taken to decrease to half of its original value. Now, the second part, a sample of wood contains carbon-14 to carbon-12 atoms in the ratio of 1 to 4 times 10 to the power 12. Calculate how many years ago the tree died. Wow, I don't like to calculate date stuff. You know how I do it? I thought of a simpler way to do it. I'm not good in memorizing all this equation probability. I'm not good at it. So that is why I need to have my own way in doing stuff. But if you think that this method is useful to you as well, feel free to use it. Right? So I'm going to do it like this. I'm going to split it into two parts. One is, okay, because this is carbon-12 and carbon-14. So the ratio is 1 to 4, right? So I write down 4 times 10 to the power 12, right? And then when the time is equal to 0. And then when it decay, because the question did mention that this, I want you to see this, amount of carbon-12 in the dead organism remains fixed. So the one that will undergo decaying process is carbon-14. So what you do, you divide 2, because decrease by half of its original value, I get 2 times 10 to the power 12, right? So from here, I need to get back 1, right? So this is 1 half-life. This is a symbol of half-life, which is 5,700 years. And then keep on dividing. Oh, I divide 2, I get 1, right? Which is equal to carbon 12. Now, how many times that I divided by 2? I divide 2 by twice. So this is 2 times the half-life, which is 2 times 5,700 years. So I get 11,400 years as the answer. So 11,400 years ago. Now C, other radioactive isotopes have different half-lives. Suggest a use of radioactive isotope with half-life of 1 hour. Only 1 hour. Explain why a short half-life is suitable for this use. Normally, you want it to be easier. Do you you look at, like, sometimes, yeah, you want to scan MRI scanning, PET scanning, CT scanning, something, okay? Especially MRI, right? We use some radioactive isotope, or chemotherapy for a tumor to kill the cancer cell, right? So you want to perform the diagnostic, right, of something or growth in your body. We need to use some radioactive isotope to help us to find that problem, right? So the use, I say, in medical field, diagnosis in medical field. Explanation, right? I said that radioactive isotope, okay? Radioactive isotope, okay, must be long enough, okay, to stay in your body to perform diagnostic, and short enough to not remain inside the body. Must be just nice. I want to perform the diagnostic only, and then I don't want it to stay too long in my body, because it could cause mutation of the cell and harm to your body. Right? Number 11. This is the last question. Number 11A, part 1. State the name of one planet that has an orbit further away from the sun than the Venus. So I say, because I like Saturn, so Saturn. Neptune also can. Now, the second one, state the name of one planet that has an orbit closer to the sun than Venus. The name is Mercury. B, Venus has an average radius of orbit 1.1 times 10 to the power 11 meter, and and an orbital period of 220 Earth days. Calculate the average orbital speed of Venus. Give your answer in meter per second. So orbital speed is 2 pi r over period. So 2 pi, radius is 1.1 times 10 to the power 11. Period, 220 Earth day. 1 day on Earth is 24 hours. 1 hour, 60 minutes. 1 minute, 60 seconds. So when you use your calculator, you should get 3.64 times 10 to the power of 4 meter per second. So 3.64 times 10 to the power of 4 meter per second. C, state the relationship between orbital speeds of the planets and their distances from the sun. Actually, when you get further distance from the sun, right, the gravitational force acting on the planet is weaker. That is why the orbital speed is smaller. So further away from the sun, orbital speed are slower, or orbital speed is slower. Orbital speed is slower. That's it for 1 mark. And D, comets are balls of ice and dust. Some comets orbit the sun. State how the speed of the comet changes as it orbits the sun. Explain your answer using ideas about conservation of energy. You may include labeled diagram in your answer, a diagram which you have to label. So I said that this is a sun, and then this is the path of the comet. Path of the comet must be elliptical, remember? Oh, my sun is not round enough. Give me a while. Okay, I draw big and round sun. And then, okay, this is, not touching. Okay, this is like not touching, elliptical. Okay, at point X. And then this one is at point Y. So this is the sun. This is comet. Right, so I will explain. I said that, okay, comet has elliptical orbit at x speed of the comet is larger or higher as it is closer to the sun and has more kinetic energy. At y, since the distance of comet is further, the kinetic energy is lesser as the speed decreases. So they asked us to use the principle of conservation of energy. Of course, I will state that there is interchange between gravitational potential energy and kinetic energy as comet moves around the sun. When you assume that there is no energy loss in between. So when the kinetic energy is lower, that also means that the gravitational potential energy is the highest. When the kinetic energy is the highest, that also means that the gravitational potential energy is the lowest. Right? So that is all about the discussion. So if you have any hesitation, you need the answer here, do not hesitate. Just comment your email below. I will email you my answer. So thank you very much for watching and see you in my next video. Bye.